Let's look at problem 57 from OpenStax College Physics, Chapter 28. What is the kinetic energy in mega electron volts of a pi meson that lives 1.4 times 10 to the negative 16 seconds as measured in the lab and 0.84 times 10 to the negative 16 seconds when at rest relative to an observer, given that its rest energy is 135 mega electron volts? So let's start writing down our knowns and unknowns. And the first thing we know is that the pi meson lives, so we have a delta t is 1.4 times 10 to the negative 16 seconds. And then we have another delta t for the pi meson, which is 0.84 times 10 to the negative 16 seconds. So one of those times has to be the proper time and the other one is a dilated time, and we need to figure out how to determine which one is which. Now, just from the terms proper time and dilated time, dilated means longer. So just comparing these two numbers, it's pretty clear that delta t has to be the dilated time, and this 0.84 times 10 to the negative 16 seconds has to be the proper time. But how would we tell otherwise? So when we read through the problem, we're told that this amount of time is when at rest, so when the pi meson is at rest relative to another observer. That means that its time is measured at rest rather than the time of the meson here in a lab. So the meson is moving through the lab is stationary with respect to the meson. Here, the meson is moving, the pi meson is moving in a lab, and its lifetime is measured in the same frame in which it's moving. So that's what makes this the proper time. Now, what else do we know? We know that the rest energy of the pi meson is 135 mega electron volts. Rest energy is E naught, and that is mc squared, and that's given as 135 mega electron volts. An electron volt is 1.6, so 1 electron volt is 1.6 times 10 to the negative 19th joules. Mega is 10 to the 6th. So 135 mega electron volts is basically 135 times 1.6 times 10 to the negative 19 times 10 to the 6th joules. But we don't have to convert that because we want the answer in mega electron volts. Now the question is, what is the kinetic energy in mega electron volts? So the unknown is the kinetic energy. So remember that the total energy is kinetic energy plus rest energy. So that means that the kinetic energy is total energy minus rest energy. Total energy is mc squared divided by square root 1 minus v squared over c squared. And rest energy is just mc squared, which means that kinetic energy is mc squared times 1 over, why did this get bigger? Square root 1 minus v squared over c squared minus 1. So we don't know the velocity of the pi meson, but we were given the information about the proper time and the dilated time, so we can use that. And we know that delta t is delta t naught divided by square root 1 minus v squared over c squared. So if I divide both sides by delta t naught, I end up with delta t over delta t naught is 1 over square root 1 minus v squared over c squared. So that's really cool, because in this expression I have 1 over square root of 1 minus v squared over c squared, and the same expression is just delta t over delta t naught. So I'm going to plug delta t over delta t naught in there and get kinetic energy is mc squared times delta t over delta t naught minus 1. So mc squared was given to us as 135 mega electron volts, and delta T was 1.4 times 10 to the negative 16 seconds. Delta T naught is 0.84 times 10 to the negative 16 seconds minus 1. And when we plug in the numbers, we end up with 90 mega electron volts.